So before the end of the previous session, somebody said that there is a problem with the insertion sort. Are you there, Ma? That evaluation is not being done.
Sir, she said that she did not complete the evaluation, so she wanted to extend the time.
Okay, so I have already extended it up to night 7:30. Yeah.
Sir,
Yes, Manoj.
sir,
Yes, Teja, tell me.
sir, in selection sort we had did the code, but when they are getting two same numbers, it is not occurring, sir, ascending order, that order. So it is no problem that if two same values are given, sir.
No, there will be no problem. Yesterday I have shown you, right?
Yes, sir. Means the same code I have also tried it, but when there are two same values, it is showing that it cannot form in a sort out, sir. It cannot sort out that
No,
order.
it started for me, right, yesterday?
Yes, sir. Means we have to create the code. It should be sorting the even the both values, sir.
Yes, of course. You should
Oh.
consider all the test cases. So somewhere else you observe what is happening exactly using that Python tutor.
Yes, sir. I will check it out, sir.
Hmm.
Thank you, sir.
So, okay. So in the previous class, we are just understanding how we can create a linked list and how we are inserting the nodes into the linked list. Remember why we need a duplicate. So let us talk again. If you don't have a duplicate, what will happen? So for example, you have these nodes 5, 20, 16, 100. So these are the nodes that you got. Now you said this is root, right? This is root. Just a second. It's very hot today also, so I have to switch on my AC. Okay, right. So we have this root, right? Here we have the root. So if there is no traversal, let us think like this. If there is no traversal, what will happen? So I'm writing something So I will say if there is no traversal, while root dot next address not equal to none. So I will say root is equal to root dot next address. So this is a statement which acts like a culprit. What happens now is that if you want to insert a new node which is having the value 110, for example. So what you need to do every time until you find none, because this is none, right? Until then you will have the addresses one after the other. So every time you have to go, the root has to be from this one to this one. Now the root will become this with one iteration. Now the root will become this with one iteration. See, all the while, nobody is holding the address of 5 and 20 and so. So they are lost in the universe. Somebody has to connect it, right? Otherwise, they are lost in the universe. Memory is like universe. It's very big. So if you don't keep a catch on or an eye on it with some variable, this address will be lost and you cannot come back. Going forward is very easy because if you are here, you can go forward based on the next address. But how can you come back? Because you cannot come back and nobody is holding your address. The root, if it finally goes here and say the root, and so you directly connect it to this one, and this becomes the last. And where the root is currently holding this one. So if anybody asks you just print the root linked list from root, it will only print 100 and 110 because root is here. It lost the previous things. They are not even existent in the memory. So these are all lost. And that is the reason why I am keeping hold of these things. So here you see, I am keeping hold of the starting node like that. I am keeping an eye on it. So 2101 will be held by root. But I created a duplicate traverser which first holds what is held by root. అంటే రూట్ ఏం పట్టుకుంటుందో అది పట్టుకుంటుంది అది కూడా లైక్ ద అడ్రస్ 2101. So whatever the root is holding, the traverser will also hold at first. And then the traverser slowly moves from one node to another node. But we are not disturbing the root. The root is still held by this one. So this. So we are having a particular catch on this particular one. Even though the traversal is moving, root is still holding the topmost node, the root node, and hence we are keeping an eye on the whole set of linked list. Otherwise, it will be lost. Maybe I'll show a small example to you so that you will understand this. Hmm. What can I do? Yeah, I will show an example like this. I'll keep this code like that. So I will show you what will happen if this is the case. So here what happens you see. So I will say root is equal to node of 5 comma none. So I'm sending these two. So none should not be kept as string. None is none. None is already defined. So it's like a variable itself. Whenever you say none, it understands that it is like zero. So yeah, sometimes you might confuse that, oh, none is like string, so I need to send it like this. No, don't send it like that. None is none and it holds nothing. So it's already defined, and that is the reason it says that it is a recognized keyword. So you can see the blue color. Recognized keywords are sent are given with blue color. Here in this case, the class, def, and if, everything. Now we write the same code instead of writing like separate one, like a function. What I will do, you see, I'll write here the same thing without any function. I will write it in the main itself. So I'm creating a new node, and what happened to it? Okay, v is not there. So this is the next value it wants. I want to insert that one every time. So this is 20. The first thing without function, this is the difficulty, of course, and I will also tell you. You know the functions are very useful because this is the way you can now know what is the use of functions and also the duplicate value root root. Root. Okay. So now you see, if I want to include another one, I need to use the same thing. So I will write a comment here. I am inserting 20 into the linked list. See, so here I am inserting 16, right, into the linked list. Copy the whole thing. So this time I want to insert 100, right? 100 into the linked list. Okay, that's all. Let us keep it like this, and we will say let us print what is the root now. So I will tell you what is the root when we come to this one. Then we will understand what happens exactly. So see every time what I am doing. First I created a root called node, and okay, fine. And a new node I have created, and using while loop I am connecting to my roots node. Okay, until now it will be fine. From next time onwards, what will happen? You see, if I directly use root, so I'm not using any duplicate things. I am creating the first node and holding its address in the variable called root. So its address is stored in a variable called root, and from there I am hanging out. So every time I want to insert a new node, I am going through root only. Let's see what will happen now. I'll reduce this one so that you will have a look into that. Okay, you see, class is created, main is called, now root is being created. Okay, this is the root. Now I see carefully in the memory side. Now it is held by root, and we are creating a new memory for new node. Okay, this is another instance. Now it's our turn to connect them. That's fine, it is connected. Until now, okay. See, the root is still holding the first one and the second one is connected. That's fine. You see what will happen next. So another new node will be created. And so this is the new node that is created. You can see. So root is holding the first address, that is nothing but holding the 5 value, and the 5 value is holding the next node as 20th value. Okay, that's fine. Now what happens if we move the root? See the line number 28 and 29 and observe the memory also. What is happening in the memory? We are just now moving the root. See what happened. Where is 16 now? Where is the previous value? Oh, sorry. Where is the previous value 5? It is not created, right? It is not done. Oh, I'm sorry. I'm trying to create 116 and all. I'm sorry. Here it is 16. This is 100. Okay, fine. Now you see, you missed that 5. So 5 is gone into the universe because you are moving your root, and nobody is holding the address of the first node, and the root which is holding the address of the first node is moved to the second node. That means 5 is deleted. So we're not catching hold of 5. Now the linked list, it says that the 20th value node is the only root node. See what happens next. So here 20 is connected to 16. This is also fine. But we already lost 5. See what will happen next when we are trying to connect 100. So 100 is the new node. So see, okay, 20 also lost because we are moving root to the next one. So wherever the root is, it is thinking that it is the only first node. And the other two nodes are lost because nobody is holding their addresses. And we don't keep any eye on their address. So finished. మనం దాని గురించి ఎటువంటి పట్టించుకోవట్లేదు, అసలు పాతవన్నీ వదిలేసాం, రూట్ని మూవ్ చేసేసుకున్నాం. దానివల్ల ప్రాబ్లం వచ్చింది. దట్ ఈస్ ద రీజన్ వై వీ హ్యాడ్ దిస్ వన్. And you can now understand why I'm using a function to insert. So this is the advantage of using the traverser as a duplicate of root. Root still holds the first address, and every time the other things get connected because of traverser. I hope you are now understanding, because traverser holds the traverser starts at the root's address and then go beyond that. But root still stays in the first address itself. So you're not losing the links to the first node. And the other thing is, see how many times I have repeated the same statement. Why should I repeat these same statements again and again if I want? So I write one function like this, and I just call that function by sending the values. It's too easy for me. And this is the reason why I have used the function and also a duplicate value. I hope you understood what is the use of duplicate value. So that we are at a time catching hold of the first node and we are not losing it, and we are traversing from one node to the other node, starting from the root. So because every time root holds the first node, the traverser starts every time at root, and from there it goes on searching for it. It's quite easy for you to understand this one. Why we use duplicate? Why can't we use directly root? Now I want the display of all the numbers in the linked list, all the elements in the linked list. So I want display. So here also I will start with the root. So I will have a duplicate because it has to move to read all the values, right? And just traversal is enough, no need of any values. Now can anybody suggest me if I call something like display of root? So I'm telling that with the root, you start reading from the root to the end of that linked list. So I'm telling that wherever the root is there, you go to that node, to that address, and you should read the value in that address, and go to its next address and read its value and print it, and go to this next address, read its value and print it. So, and go to the next address, read its value and print it. So this is how you need to write the code now. So again I'm repeating it. In display, what I am telling, please note that I am sending root address. So when the address is received here, the traverser starts at the root's address, that is nothing but which is the node holding value 5. From there onwards until the none comes, it goes on reading and printing the values. Again, traverser is equal to traverser next address, goes on reading and printing the value of that particular instance. Can anybody tell me the code how I should write it? It's very easy. Few lines less than the insert. Waiting for your hint. So I received the address of root, which I am allocating it to traverser. Now what's the job of traverser to do? So that you need to print all the values in every node of the linked list by going through linear fashion, one by one.
Using while
Sir, I
loops
think we
and
have to use while loop, sir.
Yes, that's correct. While, tell me,
Transversor dot next add is not equals to null. Num.
traverser dot next add not equal to none. Okay, fine. So up to that node you will go. The node where none is there, you will break the loop and you print the value. Up to that, what you need to do now? So you entered the loop. What will you do after entering the loop?
We have to print the value, sir. Transversor dot v. Print transversor dot v.
So print traverser dot v, not v. I think it's value, right? Because it it will have access to its value. Okay, right. Next, we printed the value.
Traverser is equals to traverser dot next add.
Okay, traverser is equal to traverser dot next add. This is the reason why we are getting the error previously. Well, and 21, why that error comes?
Sir, you're not audible.
Yeah, in line number 20 and 21, what could be the mistake? That is the reason why it says that it stopped after running 1000 steps. Am I audible now? Have you heard what I said?
yes, sir.
Yeah. So that means it is going to infinite. That is the reason why it stopped at 1000 steps. Why we need 1000? Because it is infinite, it is going 1000 steps, and it is saying Python tutor cannot handle infinite. So now tell me, what is the mistake that you are identifying in line number 20 and 21? In which line actually there might be some error? What is traverser? At this current position, what is traverser?
Root, sir.
It is holding the address of the root itself. It is not none, that's why you are printing it. If you are not writing the next line which I have previously written, again it will go to the while loop and traverser remains with the root only. So it is infinite loop. Traverser will always be in the root and root's next address is not even none. Every time it prints, goes on printing 5, 5, 5, 5, 5, 5 until unless your memory is full. So to eliminate that infinite loop, we have to write this line because it is going one by one. So traverser is equal to traverser's next address. Until the traverser's next address is none, we need to repeat the same statements again and again. Okay. Ah, so where is the cursor? So done it. So after you see in the print statement, it is running 5 20 16 has been done. But I think last 100 is also there. So according to our case, see that 5 20 16, then it will stop at a node called none. It says, right, if the traverser comes to the last node, It does not satisfy the condition because traverser's next address is equal to none. But what I said, if the traverser's next address is not equal to none, then only enter the loop. But if in this case, if traverser is here, where I am highlighting now, the node, the green color highlight, you see here my cursor. If the traverser is at this node and its next address is none, so it will come out of the loop. And after it comes out of the loop, what should it do now? I need to print 100 also. So what should it do now?
Print traversal dot values.
Yes, that's correct. So it will be print traverser dot value. That's all. So you see that 100 is also printed. Now we will go through the code so that we will see how it is displaying. So we are creating insert display main functions. We are creating our first root node. Okay. And then we are inserting the second node for that. You need to create new node into the insert function. The next thing is using traverser. You are trying to connect it. And the next node, it is 16. And using traverser, you can observe the memory that it is being connected. And the next one, insert. So using the traverser, the new node is again connected. You look into the traverser, what it is doing, because it is going through the while loop. And finally, the traverser is connected to the last node. Now we are displaying it. You see how I am displaying it. Now you see in the display function, the traverser is pointing to the root. Next, what did I do? I am checking whether the traverser's next address not equal to none. Yes, it is not equal to none because it is having another address to it. So none means it is not holding any next node. But here it is holding the next node address. Yes. Now think them like you're trying bogies. So this is the engine, and these are all linked to other bogies. This bogie is linked to this bogie, and this bogie is linked to this bogie, and this is the last bogie where your guard will be there. And we call it as a bogie with none value. Okay, there are no bogies decided. And have you seen that the last bogie of every train will be kept with a cross mark? Have you observed or not? When the train is going, the last bogie will have a cross mark. That means no bogie should be attached to it. That's called non bogie. So it do not have any link also to it, so that no other bogies will be attached to it after that. So that's the end of all the bogies. That is the reason why they will attach the cross marked bogie at last, and most of the time the guards will be there in that. Okay, now see the traverser is printing the traverser value because the traverser is now, you see, it is holding the root node, and so its value is there, and its value is 5. It will print 5 onto the screen, and you can see what is happening in the screen. Okay, and now your traverser is equal to traverser next. You see, the traverser's next address is connecting to this one, so the traverser will come here because you wrote traverser is equal to traverser next address. Now here you will again check whether it is not equal to none. Yes, it is not equal to none because it's holding next address. So print traverser value, which is nothing but 20. So on top of the screen you can see that 20 has been printed. Now traverser is equal to traverser next address. So now the traverser will be holding this node, you see, because it's the next address. Yes. So here again, you will check whether it is none or not. No, it is not none because it is already holding another address. So print traverser dot value. So it will print 16. So now traverser will move to the last node which is having 100 because traverser is equal to traverser next address. This is the next address, right? And hence the traverser will move to this next address. Now it moved to that. That's exactly fine. So Finally you have read all the way. So you will check again in the while loop, because you see we are in the 20th line still. So traversal next address is none or not. It is equal to none. Hence break the loop and come out. By the time we are not printing still the 100. After breaking the loop and coming out, we are printing here. So we are in the 24th line. Here you are printing, because our current traversal is holding the node with value 100, right? You see the red line. Okay, now you can simply say print traversal dot value. It will print 100. That's fine. End of this one. We have displayed it. That's all. So you now know how to build and how to display. Now can anybody tell me how you can delete the end node? I want to delete the node 100. Next I want to delete node 16, end node. Everywhere I want to delete an end node. So you know how to display it. So now after finishing this, you can practice it. So I will also tell you how to delete it. Delete traverser. So I will call it like delete root. So if you say delete a root, so this function will be called, and you need to write some logic in such a way that your last node will be deleted and the linked list will be only 5, 20 and 16. Again, if you call delete, the last node this time is 16, so the linked list will be only 5 and 20. Now anybody can tell me what could be the logic behind it.
Or while using while loop and if condition.
Yeah. You can use while loop, but how do you know that you should delete this node? This
Sir, if
node.
traversal next add is none, it
Yeah,
will
tell
delete.
me. Tell
If
me.
traversal next add is none, sir.
If traverses next address is none, so that means by the time the traverse, you are expecting the traverser has to come here, right? And how do you delete this one? How do you delete this link?
Sir, it should not come to the last one, sir. So it should be deleted
Ah,
before one, sir.
that's
Before one should
correct.
be getting none, sir.
Yes, if you want to delete this node, your traverser should not come here. See, deleting the node in the sense it is not erasing with a rubber. It's erasing the address here and making it none. Then you have only 5 and 20 because the next address is none here. So that's how the deletion happens. So this address which is held by the second node here will be deleted, and instead of that we place it none. So this is going into the universe. So we are deleting this link. Imagine the train also. If you go, see, if you go and stand to the last node, how can you delete that node? How can you delete that bogie from the train? You should not go to that bogie, right? You should go to the last but one bogie, stand at the edge of that bogie, just remove the link so that the last bogie will be left away from the train. That's what happening, right? When you view the movies also, the hero will stand at the last but one bogie and he will just remove the link, and so that the last bogie will be separated from the train. The same thing happens here. So our hero should jump from one bogie to other bogie, go to here and delete this link so that it will become none. So this will be separated from the list. That's what deletion means. Now, you need to write down the logic now. Tell me how to write the logic. So your traverser is your hero. Now tell me how do you do that? Imagine Chiranjeevi or somebody going through the train and removing the link. Now move your hero from one bogie to other bogie. How do you do that? And you should find that it should not be the last node. It should be last but one node.
Sir, same loop you have to use, sir. We have to loop until transversor dot next is equals to none, not equals to none.
Okay, right. Let us write while loop, right? Traverser dot next address not equal to none. So if you are doing like that, it will go up to the last node, right? Here also we are giving
Equal to none, we can.
Emma? If you
Sir,
keep equal to none or not equal to none also, it will do the same thing.
16 వాళ్ళకి వెళ్తుంది కదా సార్.
Yes, sir. If we give no equal to none, it will go to
పోనీ
16.
అలాగే చూద్దాం. ఈక్వల్ టు నన్ కావాలా మీకు? యూ వాంట్ ఈక్వల్ టు. So according to you, if that is the case, then traversal is equal to traversal dot next add. Okay, let us see here. So delete. It is coming like this. Okay. So while traversal dot next is equal to none. Now what happened now? Nothing is deleted because the first node itself is not none, so it will come out of the loop. Now what is the next case then you will write? So whatever you imagined is wrong. What is the modification you need to make me do this?
Sir, not equals to none, sir.
Okay, we will keep not equal to none.
After while loop, traversal dot next is equals to none.
After while loop,
Traversal dot next
traversal
address
traversal dot next address is equal to
equals to
sorry
none.
is equal to none. Okay, that's very fine. Let us go to the previous one. Okay, right. Okay, now we are getting to delete. So traversal is starting at root. So you will find out so that the traversal will move to the. So actually here the traversal should stop right at the 16th node, the red mark. But see what will happen. See, it came to the last node already. So our hero at the last bogey, what he will do now? వచ్చిన సౌండ్ వస్తుంది ఎందుకంటే అది అయోమయం అయిపోతాడు. He will be surprised. Oh, I am in the last bogey. I have to remove the last bogey. Again, he has to go, to the last but one bogey. Now, what is there? Already that is none. And what is this use of this statement? Line number 32. Again, you are making the same thing, right? That's all. None is none. You are giving none. That's all. How do you stop at node 16? That's where I want.
Sir, using another variable and storing before value.
Yeah, that's fine. But the other thing is, I can ask you one thing. I will ask you here. I will write something for you, and I'll ask you now. So, for example, the traversal is here, right? The traversal is here. Now I will ask you a few questions. Tell me, what is traversal dot next address? Can you tell me what is traversal dot next address?
3620.
Yeah, 3620, because this is traversal dot next address. If I write like this, what is traversal dot next address dot next address? Can you tell me what will be this one?
None, sir.
Yeah, what is traversal? So you can divide like this. You can divide, break down the problem like this. What is traversal next address? You already got, right? 3620. So this is 3620. What is 3620 dot next address?
It's none, sir.
None. So can we use this statement in our while loop? That
Yes,
means
sir.
while you are in the before bogey, you want to find out the next bogey is the end bogey or not. So this statement will be very much useful in your code. Let us go to this. While traversal dot next address dot next address. Okay, now you understood what is the meaning of this, right? Because the traversal's next address is the next address itself. And each next address we are calling is not equal to none. So before going to the next traverse, the next node, we are sitting at the before node only and finding out whether its next node's next address is none or not. Understand, again I'm telling, sitting in the last but one node itself or the before node itself, we are trying to find out whether its next node's next address is none or not. That's what it means. So it is nothing but next address, and its next address is none or not. So now it will work for you. Now you see what will be done. So we come to the previous. Ah, So we come to the delete now. You see traversal, and it finds traversal's next address, next address. That means next address is this and its next address is this. Yes, it is not none. So naturally, it goes inside and goes to traversal. Now, when we are at node number 20, it is now checking the node number 16's next address. It is not none. Fine. Now we can go to the 16th node. And when the traversal is at 16th node, now it is checking the 100th node next address. Okay. So it is none. So see what will happen. It comes out of the loop and comes to line number 32. And still the traversal is at 16th node. Now it's easy for me to make it none. Yeah, finished, right? We have deleted it. So 5, 20, 16 only will be remaining. That's all. Come back. Finished. So I hope you understand what is removing or deleting a node from something. That means if you want to delete a node from a linked list, you need to delete the connection that is already present with the previous node. That's what deleting means. So for example, imagine the same, not only the train example, you can also see if you're in a universe, if you're an astronaut, until unless there is a chain that holds between you and the space station, you can walk around the space station. If the chain is cut off, what will happen? You are not killed actually, but you will lose connection with the space station. The same thing happens here. The 100 has lost its connection with this list, linked list. And hence only 5, 20, and 16 are there in the linked list, and 100 is there still in the memory, but it is not, we are unable to see it because we lost connection to that. So that's what it means. Any doubts in this?
Sir, can we delete middle elements now?
Yes, definitely we can delete middle elements. But once you try to practice this one, then we can go for middle elements. Because middle element understanding means you see, you need to understand like if you want to delete 20, once you just cut off 2016 will also get deleted. But the 16th address should come to 5, the next address, and the next address which is holding this 20th one should be deleted. So this will be little bit thought oriented, logical. So before that, you need to have a hands-on practice of these things. Then you will understand that middle element deletion. So I encourage you now to practice this one. Please open your Python tutor. I'm not creating any assignments now. I will create assignments later, but I want you to practice it. Open Python tutor, write the code by understanding it in live session. So you have two buttons, right? In Python live session and without live session. Open live session and please try to write the code by understanding what is happening in the memory. If you have any doubts, I will be there to clarify it. Please open now, all of you. I just said if you don't practice it now, you will entirely forget everything that I have told you until now. Now practice it, please. So if you want, I will send this code to you for your reference. But how to send it? If I send it in your CS group, there is no separate Python CS group, I think, for you. It is an all-rounder group, I think. Everybody will see that.
Sir, we have it, sir.
You have it. Can you just keep a reminder for me so that I can copy now?
Yes, sir. I'll keep a message in that group, sir.
Yeah, keep it. So it's only for you I am giving, but You know, it is not about copying that one. Just for your reference, I am giving it. Yeah, I got it. So just now I have sent it to you. See. Yeah, if you really want, I can just give a small hint about deleting the middle node. I think by this time you might have already got it. If you try it, it's very easy. See, if I want to delete the 20th value, I want to delete the node with 20th value. Can anybody tell me what could be the logic? Earlier logic is if you find that a node's next address is none, then delete it. But here we want to delete a node based on the value. How do you write it? Your traverser is here, and we know that if the traverser comes to 20, then this is very bad. But if the traverser is here only, we can do something. So any logic? If the traverser
Sir,
is not here,
261.
yeah, just a second. Yeah, the traverser is here. And tell me.
We have to set the address of 5 to 3620, sir.
Yes. So that means the address that we got, the 2610, should be set to 3620. Yeah, that's fine. But still, what is left? So I need to set it to 3620. Then only I have a direct connection. How do I do that now? What is the statement that you can tell me to do that? Because your traverser is here. And how do you find the address of the node bypassing 20? That 3620 should be replaced instead of 2610. Any idea? Any guess?
Sir, we have to store the address of 20 in one variable, sir.
Yes.
After that, we have to connect the address of 5 with the 16.
Hmm. So first of all, you need to find out the node which is having 20, right? So can we do like this with the same statement? So the same statement which I am underlining, because the traverser's next address is 2610, right? Because if the traverser is at 5 here in this location and its next address is nothing but 2610, right? What is 2610's next address? 3620, right? In this case, now that's what we found out. But how do you find out the node's value is 20 or not? Because if we want to delete 20 from the linked list, can we write a condition in the while loop if traverser dot next add dot value is equal to 20? Can we write like this? So our traverser is a 2101. What is traverser's next? Can you tell me? What is
2610.
2610? What is 2610's value?
20.
20. So 20 is equal to 20. That's fine. Now what will you do now? Because you already found the node is there just beside you.
We have to
So
remove it.
yeah, we have to remove it. How to remove it? We cannot erase it, right? What is the next thing that you do?
Storing the next address.
So you simply say traverser's next address is equal to traverser's next address dot next address. Did you understand this one? So
Yes, sir.
initially, yeah, your initial traverser's next address is 2610, but now what you are equivalent to? Traverser's next address dot next address. That means traverser dot next address dot next address. So the traverser's next address is nothing but 2610. Dot next address is nothing but
3620.
3620. So
We'll
your
skip it out.
now traverser's next address will become 3620. So it is done, and your link is connecting from here to here. So this is eliminated because you are bypassing it and connecting it to 16. So your only 5 and 16 will be there in your linked list. So using this logic, try out. You will use the same while loop. Instead of if condition, you can use the while loop. Okay, and go on repeating it. If it is satisfied, then you just remove that link and connect to its alternate link. You can just try out for this logic. Okay, right. We will stop this class now. So today you learned how to insert, display and delete, and you got a hint on how to delete an element in the middle. So try these things for these 2 days. So in the next class we will discuss another thing. I think your schedule has come. This time I think both DS and CS are having the same day exam. I think all IoT, DS, cyber security, and the what is the other one? AI and ML. All are having on the same day. Thursday, I think you have a class, uh, but I don't know whether they have a class or not. Okay. Okay then. Bye bye for today.